Just kidding. I wanted to give you the pan out version. What if I came in? And no. Just kidding. So I'm going to video myself teaching you guys lessons. That way you're not just like doing online stuff the whole time. You actually get like a break to be like, you know what? I miss Coach Shelton. I knew you would. I knew you would. So, yeah, I'm going to video myself teaching this stuff. It's probably going to be lame. What I do want you to know is, feel free to take notes, because any notes that you take when you watch me teach, you can use to take the test. Alright, I know you don't have outlines, and so this is just a compromise. Easiest way for you guys to get the material, and easiest way for you to have something to help you on the test. Every question on your test is going to come off the information on the PowerPoints, so feel free to use your notes if you take them. I suggest that you take them, because I make my own tests, and it will be on Google Classroom in a locked browser, so please take notes. Alright, so this is on speed and velocity. It is not that bad, I promise. This is actually a fun lesson. This is a lesson that we were going to do all of our like relay races in, like bear crawl and crab walk and all of this really lame stuff that you like to do, like wheelbarrow races and that kind of stuff, but coronavirus got us down just a bit, so instead of doing this, you're laying at home in your pajamas watching me teach, which you probably like a lot better. So, speed and velocity. An essential question. How can we describe the motion of an object relative to a reference point? Now remember, reference points. That's going to be very important. A reference point is a point of reference, so you can be able to talk about the description of where something is located based on that. Now remember, we said reference points need to be like solid objects that do not move, right? Cars don't make good reference points. Why? Because they move. People don't make good reference points because they move. Walmart, well, we said it made one, but remember then we talked about it growing legs and running off, and so, I'm just kidding. It will make a good reference point. So, as long as something cannot move, it is a good reference point. If it can move, not a good reference point. So here we go. Two vocabulary words that you need to know. A scalar versus a vector. Scalars are measurements that tell you how much. Examples, length, speed, and temperature, alright? So they're just telling you like precise measurements of something. It will be a number. So when we're talking about speed, we'll say like 30 miles per hour or 10 meters per second, something along those lines. It's just giving you a measurement. A vector not only tells you the measurement of how much, it will also tell you what direction is it happening. So examples, like that would be velocity. The difference in speed and velocity is speed says 30 miles per hour, velocity says 30 miles per hour north. So, scalar versus vector. Alright, what is in motion? Motion will be on your test. Write it down. Alright, motion is the change in position of an object relative to a reference point. Now they have this rubber duck as the reference point. Technically, is the rubber duck a good reference point? Actually, that's probably a real duck, but since Judah's birthday's coming up and we're doing a rubber duck theme, I've seen like 1,000 rubber ducks, so that's why I say, oh look, the little rubber duck floating in the ocean, because that's a normal thing. No, that's a real duck. So the duck, does it actually make a good reference point? No! That's right, class. It does not make a good reference point. Why? The duck can move, alright? So it doesn't technically make a good reference point, but just for the sake of this picture, we're using it as our reference point. Now behind it, we have a baby shark, baby shark, I'm just kidding. Alright, we have a shark, alright? In comparison to the duck, how is the shark moving? Well, we would say the shark is moving relatively fast, or fast, relative to the bird, right? In the bird's opinion, that shark is moving lightning fast. So, yeah, the shark is moving a lot faster than the little bird and his feet, okay? At the bottom, we have a snail and a blade of grass. While we know snails are slow, alright, it is actually moving relative to the grass. So the grass isn't moving, and although the snail is moving very slowly, it's still moving, alright? Considering our grass, the reference point, is not moving at all. What is motion? Ask Galileo. Galileo, What's motion? All right? He would say if the Earth is spinning at 1,000 miles per hour and also moving at 67,000 miles per hour in an orbit around the sun, why can't we feel it? All right? We're going to watch a quick little video. Hopefully you can see it.
If, like a galloping horse, the Earth is moving through space at great speeds, why can't we feel the movement? Galileo thought it was possible that the Earth could spin on its axis fast enough to cause night and day without anyone being able to feel the motion.
What is really exciting about Galileo, and you see it exactly the same in Einstein too, was the way he picked up what seemed to be an absolute impossibility. He said, we have this incredibly strong evidence that the Earth is not moving. Everything that our senses tell us is that the Earth is not moving. And yet, Copernicus has got these rather strong arguments from astronomy to suggest that the Earth is moving. So then Galileo says, well, this actually should tell us something very deep about how nature works.
In Galileo's thought experiment, a horse represented the motion of the Earth. If the rider dropped a ball while the horse was standing still, the ball would, just as one might predict, fall straight down, landing beside the horse. But Galileo thought, what would happen if the ball was dropped while the horse was moving through space in a gallop? Would the ball now fall behind the moving horse? No, thought Galileo, for in his thought experiment, the forward motion of the horse would be translated through the rider's hand to the ball, so that when the ball was dropped, it too would continue to move forward, landing beside the horse just as before. He thought when the horse and the ball shared the same forward motion, it appeared as if the motion didn't exist. So, Galileo reasoned, it is possible that, like the ball and the horse, we are sharing the motion of the Earth without being able to feel it.
There is a sort of a principle of relativity where if you're sort of moving with the Earth, everything shares the same motion. Not only is the Earth moving, but I'm sharing that motion as well. And therefore it is all hidden. It was probably the first really great thought experiment in physics. In fact, he was so confident of the result, he never bothered to do the experiment to show it was right.
Oh, long trek from downstairs. You know how to be lame. Adrian, you didn't like that? Hang on, let me go. I forgot something. I'm just kidding. So hopefully you guys didn't think that that video was as lame as some stuff that happens in here, but it's very cool. So because we are moving at the same speed that the Earth is moving, we don't feel the effects of that motion, is basically what Galileo found. So, what is position? A coordinating system is helpful for describing the position of an object relative to the reference point, also called the origin. So the spot where we start is going to be our reference point or our point of origin. If we were going to plot this, we would put this at 0 as the origin. Alright, in this diagram, the gas pump is the origin, so again, we label its position 0. The position x of the front of the pickup truck is x equals positive 6 units. Alright, so if we look at this truck here, we see the very front of the truck is at 6. So we say that x equals plus 6. And the position of the front of the car, this is a car, this is a truck. We've been out of school for like one day. So I know, you can forget very easily. Position of the car is x equals -2 because the front of the car is at -2 there. So that is where they are relative to the reference point. The car is 2 points behind, the truck is 6 points ahead. What is displacement important definition. Displacement is a change in position. So how much of a change we have in our position is what displacement is. Displacement, it is a vector, so that means that it will have direction and magnitude, right? If you've ever watched Despicable Me, Vector, he has both direction and magnitude. Alright, that's how he gets his name, Vector. You know, the villain that, like, he plots to steal the moon, isn't that right? The Vector plots to steal the moon? Right, he plots to steal the moon, and so that's how he gets his name, because he has both direction and magnitude. Oh yeah! Right? Some of you have no clue, because you've never watched Despicable Me, but, yeah, a vector, again, has direction and magnitude, or an amount. So the displacement, to find displacement, we take our final position and we subtract that from our initial position. So we can look at this car being our final position, right? This is where it stopped. This is our initial position. This is where it started, okay? So displacement will be final minus initial. So again, final minus initial position gives us displacement. Or displacement equals x final, the F stands for final. Some of you are like, I thought the F stood for my grade this semester. It might. It might. And xi, initial. Okay? Therefore, the car's displacement would be x final, which is 9, minus x initial, which is 4. So its displacement would be 5 units in the positive direction. Anytime we're going to the right on this number graph, our amount is going to be positive. Remember, displacement includes direction. Alright? Without direction, it's simply distance traveled. So displacement has to have direction as well as an amount. If not, then we've just looked at distance. I wish I could turn this camera around because right now Emma and Adrian are making TikToks in the back of the class while I'm trying to video this. So all I see is like, go watch. I promise you'll see it. Whoever has a TikTok account, go find it and you'll see the video that I'm talking about. You can see my desk in the background, all these cute little pictures of Judah. It's happening. Alright, what is speed? Will be on your test, okay? Speed is the rate at which an object moves a distance in a given amount of time. So how far an object travels and how quickly it did it in. So how far it went and the amount of time it took to go that distance. We have 2 types of speed. We have average speed, right? If you were to run a triathlon, you're going to swim, you're going to bike, you're going to run, okay? You can look at how fast you did each of those things, but your overall triathlon time will be your average speed, right? Of how fast did you bike, plus swim, plus run, divided by those 3 events. And then you have instantaneous speed. How quickly are you traveling at this precise moment in time? Okay? Like, this is like what I do to BJ when I'm like, BJ, slow down, how fast are we going? And he's like, only 85 miles per hour. And I'm like, 85, the speed limit's 70. And he's like, that's a suggestion, right? Me, I'm like one of those, I'm going to set my cruise control on 70 because I'm a rule follower. And I'm going to ride in the right lane so people can just zoom past me with 0 rage. But that's how I am. Alright? So again, what is speed? Average speed. Average speed is the total distance covered in an amount of time. So total distance divided by total time it took to travel that entire distance. Okay? A runner's average speed during a marathon would be found by dividing the total distance, which is 26.2. Great, good answer. Joe Bobby. Alright, divided by the total time it took to get there. So for the formula for speed, which you will be solving a couple of equations using this formula, all you need to know is speed equals distance divided by time. Alright, speed equals distance, total distance ran, total distance traveled, divided by the total time it took to travel that distance. Your units with that are going to be whatever units you're given. So if the total distance is miles and the total time is hours, your unit will be miles per hour. That line, literally just means per. Alright? So when you have like meters, when you have meters over second, you would just say meters per second. Alright? So anytime you see that line, you read it as per, P-E-R, not P-U-R. R. No cats up in here. All right, PER. So, instantaneous speed. Instantaneous speed is the speed of an object in a given instant. At that moment, how fast are you traveling? All right. The plane's instantaneous speed is given by the speedometer, same as your car. All right. I'm not sure if planes have speedometers. Do they have speedometers? I'm not sure. All right, which measures the distance the plane is traveling per unit of time at that exact moment. Right? If your car says you're going 60 miles per hour, that means in 1 hour you are traveling 60 miles. Some of you are like, oh, what? I know, right? If you're going 30 miles per hour, if you keep driving at that speed for 1 hour, you're going to have gone 30 miles. It's craziness, all right? So, again, same formula. Speed equals distance divided by time. Either way, the units are always a distance unit over a time unit, like miles per hour, all right? Again, MPH, that is miles per hour. It's the same as miles over hour. All right? Or meters per second. Okay, that's just indicating a distance unit divided by a time unit. What is velocity? Now, velocity is going to be speed with direction. All right, so velocity is a vector, meaning it has size and direction. Okay, so velocity is the displacement of an object over a given amount of time. How far did that object go in an amount of time, and in what direction was it traveling? If you don't include the direction that was traveling in, you haven't given me velocity, you've only given me speed. All right. In other words, it's the speed of an object with direction. All right? Velocity is a vector. Exclamation, exclamation, exclamation. This will be on your test. You'll probably see, like, is speed a vector? The answer is no. All right? Is velocity a vector? Yes. All right? Turtle's velocity, 4 meters per hour east. All right? We have to include the speed that it's traveling in, and we also have to include the direction in which it's going. So speed and direction. All right? And we'll call this turtle Timmy. You can't see the Y, but it's there. Timmy. All right? So yeah, speed and direction give us velocity. Formula is velocity equals displacement over time. All right? So with this, our velocity is x final. So the final position minus x initial, all right, where it started, divided by time. So final position minus initial position over time. Remember, this is different from speed. Speed equals distance over time. This, we're actually looking at where did we start and where did we finish. So we take the spot that we finished at, or the speed that we finished at, and subtract the initial speed from that. So if we're looking at a cheetah that was laying down and then he took off running, we're going to take that time, or that speed that he was running at when he took off as our final speed, and his initial speed, which he was laying down, would be 0. So we would have his final speed minus his initial speed over time. That's also how we're going to find acceleration, all of this good stuff. But what you need to know, final position minus initial position over time. All right? And then remember, we have to include direction. All right? If we don't include direction, all we have is speed. So, how can an object's velocity be calculated? An ambulance travels north to an accident 10 miles away, and it takes 4 minutes to do so. What is the ambulance's average velocity? All right, so again, velocity equals displacement over time. So when we want to set this up, again, it traveled north for 10 miles in 4 minutes. So the formula we're going to use is velocity equals displacement over time. So velocity equals 10 miles north. Why? displacement, we have to include the direction. So 10 miles north divided by our time, which was 4 minutes. So in order to solve for velocity, we divide 10 miles north by 4 minutes, and we find a velocity of 2.5 miles per minute north. Is it important that we include the direction? Yes. All right. Velocity is a vector. So we have to have our speed and we have to have the direction. All right. How can an object's velocity be calculated? In another example. Okay. A pickup truck goes from positive 4 meters to minus 4 meters in 2 seconds. What's the truck's velocity? All right. So remember, final position minus initial position. X final minus x initial divided by time. That is our formula for velocity. All right. So we're going to look at what we have. Our final position, which they told us is -4. Our initial position is +4, and divided by our time, which is 2 seconds. Alright, so the formula we're going to use, again, velocity equals x final minus x initial divided by time. So velocity equals -4 meters minus a +4 meters. Alright, when you minus a plus, it's just -4 minus 4 meters. Okay, divided by 2 seconds. So velocity equals -8 meters divided by 2 seconds. So our velocity is -4 meters per second. Now, you want to be like, hey, that doesn't really tell us direction, but it does, because we're looking at a number line. Anything that's a negative is going in what direction? To the left. Alright? If it's going in the positive direction, it's going to the right. Alright? So the negative sign just indicates that the truck is moving to the left, relative to the reference point, aka our gas pump. Alright, it also makes this a velocity instead of just a speed. Alright, speed triangle. Okay, it's very helpful in finding distance traveled or the time passed. If you draw a triangle, okay, I would do this so that I had a copy of it. Oh, Jackson joined in on the TikTok meeting, so things are getting crazy. Okay, they're doing a shimmy now. I don't know. What song are y'all doing it to? I don't understand how TikTok works. So, the speed triangle is helpful again. You draw a triangle and then you're just going to draw a T inside. Okay, so triangle, and then a T inside the triangle like so. Alright, you write the formula for speed going from left to right. So speed equals distance over time. So D for distance is at the top. So we have inside the triangle, we have the D in the top part of this triangle, S in the bottom left corner, and the T in the bottom right hand corner. So right now, well, it'll explain it. So if you needed to find the distance traveled, you multiply speed by time. If you need to find the time that something traveled, you divide distance by speed. Or if you need to find speed, you add speed equals distance divided by time. So the trick is to cover up what you want to find the formula that you need. So if I'm solving for speed, all I want to do is put my hand here. And all I'm left with is distance divided by time. So I know that the formula for speed is distance divided by time. If I want to find how to find distance, I just cover up the D, and I see that speed times time gives me distance. Alright, if I want to solve for time, all I do is take distance and divide that by speed, and that will give me my time. So that's a trick that you can have all three formulas right there inside the triangle. All you do is cover up what you need to solve for, and you have the rest. Alright, practice what you learned by answering the Sum It Up questions. I'll be typing those in Google Classroom so that you can answer those there. Actually, I'll put them in Canvas. Do them in Canvas. I'll put them there. It'll be an easy review. If you want to write some of that stuff down, you'll see it on the test. All of your tests are going to be in Google Classroom. That way I know it's a locked browser. Can you use your phone? Yes. If you're a scumbag of the earth. Alright? Don't use your phone. Cough, cough. Tie. Alright? Ty's like, I ain't gonna use my phone. I'm gonna call Reed to come over to my house and we're just gonna take it together. Bad idea. Reed will tell because he has a guilty conscience, alright? So, just take notes. That would help me out. It'll also help you out when you go to take the ACAP test. I'll have plenty of review over speed and velocity. Before you actually take the test, we'll do several things, making sure that you know how to solve for both of those. So, hope you guys are having a good day, and I'll see you later. Just kidding, I have to push stop.